discussing Unit 6 Arenes and Aromaticity of Organic Chemistry Paper 1. Under this topic, last time we have discussed electrophilic substitution reactions of benzene like nitration, halogenation, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. We have seen that these reactions proceed in two steps. First step is the formation of a sigma complex or benzenonium ion, which is a rate determining step also. In this step, electrophile attacks the benzene ring. In second step, there is a loss of proton and which is a fast step to give back aromatic system back. Now, before proceeding to alkyl benzenes, today first we discuss the effect of substituents on reactivity of benzene ring. If any substituent is present on benzene, then how it affects the reactivity of benzene, and this effect of reactivity can be in the form of activating or deactivating. So, we will see which groups are activating and which groups are deactivating, and further we see the effect of these substituents on orientation, that means on which position the attack of incoming group will takes place, and that is known as orientation, and that can take place on ortho, para or meta position. And we will see which groups are responsible for ortho para attack and which groups are responsible for meta attack. And we further discuss today the orientation in disubstituted benzenes. That means if two substitutions are present in benzene ring, then how this third group which enters will go in which position. Now, first we discuss the effect of substituents on reactivity. When substituted benzenes undergo electrophilic substitution reactions, the substituent can affect the reactivity in two ways. It can make the ring more reactive towards electrophile, then these types of groups are called activating groups, or it can make rings less reactive towards electrophile, and this type of groups are known as deactivating group. Now, what are activating groups and how it affects the reactivity of benzene ring? The groups which increases the electron density of benzene rings by donation of electrons. So, this rings becomes more prone to electrophilic attack. So, why it becomes more prone to electrophilic attack? Now, let us see. If we take this substituted benzene, this S is the substitution, can be present on any one position of benzene. So, if electrophilic attack takes place, we get the intermediate formation of this arenium ion, which contains a positive charge. So, any factor which decreases this positive charge will stabilize this arenium ion. So, if this S is electron donating group, that increases or it decreases this positive charge. So, that means it stabilizes this arenium ion, and that is why due to this stability of arenium ion, E activation decreases and rate of a reaction increases. Now, this type of groups which increases the electron density of a ring in order of their decreasing strength are, this is O minus, for example in phenoxide, this is NH2, for example aniline, this is substituted anilines, NH1 substitution, this is NN dialkyl, this is phenol, this is ether, this is a type of acetanilide, then this is alkyl benzene, esters and diaryls. So, in this order, their donation of these groups decreases. Now, this electron release by these groups may be due to two effects. The electron releasing effect can be inductive, that is a plus I effect, for example alkyl groups. Now, this electron releasing can be due to mesomeric or resonating effect, that is plus M or plus R effect. For example, OH, because these are having, all these groups are having lone pair of electrons available which can be donated to benzene ring. And further one more thing, all these groups which are having positive M or positive R, these all are having electron withdrawing inductive effect. But if we compare the two effects of these groups, then electron donation is much stronger effect than electron withdrawal. So, that is why these groups are known as electron donating groups. Now, the deactivating groups means groups which withdraws electron density from the ring, and due to this ring becomes less reactive towards electrophile. Now, let us see how. This is a substituted benzene. If attack of electrophile takes place, we get the intermediate arenium ion. So, if this substituent withdraws electron density from the benzene, then it intensifies the positive charge. That means destabilization of arenium ion. That means increase in E activation and decrease in rate of a reaction. Example of these types of groups are the group which have positive charge or which withdraws electron density. For example, nitro, nitrile, sulfonic acid, aldehyde, ketonic group, acid, ester, amide, halogens. Now, again this electron withdrawal can be due to inductive effect, which is known as minus I effect. For example, halogens, nitro, CCl3, this containing a positive charge amine group, and electron withdrawal can be due to mesomeric effect also, that is minus M or minus R. For example, again nitro is having both electron withdrawing inductive also, electron withdrawing mesomeric also. Nitrile group, ketonic group, aldehyde group, all these groups are having electron withdrawing inductive also. So, now let us see the energy diagram. So, if we see, this is the case of benzene, simple benzene. If undergoes benzene this electrophilic substitution reaction, it gives this intermediate, and this is the intermediate produces via this transition state. Now, if we have substituent which is a electron withdrawing, then you can see this is a increase in E activation. So, due to this rate of reaction decreases. Now, if this S is electron donating, then there is a decrease in E activation. So, due to which rate of a reaction increases. Now, not only the reactivity affected by the presence of a group, it also affects the orientation. Means, now if we have a one substitution, then there is a possibility for an incoming group, it can attack on ortho, it can attack on meta, or it can attack to a para position of the present group. Now, this is your substitution present on benzene. So, this incoming group can enter at ortho, meta or para position. Now, how to decide the orientation? Incoming group will go on ortho, meta or para. How we decide? All of us know that rate of a reaction is governed by the formation of an intermediate arenium ion. So, for deciding on which position the attack will take place, we compare the stability of intermediate formed by attack at ortho, meta and para positions. So, finally, the attack will take place on that position which will give more stable intermediate, that is arenium ion or sigma complex. Now, we discuss the cases. First case we discuss of toluene. This is the methyl substitution which is present on benzene ring, and CH3 is having a electron donating inductive effect. So, if we see the ortho attack on toluene of an electrophile, this intermediate will get formed. So, there is a resonance between these three structures, and now see in this first structure positive charge is present on that carbon which is directly linked to methyl group, and methyl group is having a electron donating inductive effect. So, it stabilizes this positive charge more. So, that is why this is the extra stable resonating structure. Now, these two are also contributing, but this is the most stable. So, contribution of this resonating structure is more towards resonance. So, that gives extra stability to the benzenonium ion. So, that is why the intermediate get stabilized and finally we get the product. Now, if we see the meta attack, electrophile attack on meta position and we get the intermediate, and this is stabilized via these resonating structures, and in these resonating structures no structure is extra stable. So, that is why extra stability contribution towards resonance is not there. Now, if we see the para attack of an electrophile, now again in this structure we get the positive charge on that carbon which is directly linked to methyl group. So, again this positive charge is more stabilized here. So, this is more extra stable structure. So, contribution towards resonance is more. So, now we can see the E activation curve for a reaction. This first curve is for benzene and these two are for toluene where methyl group is present. So, that is why, because methyl group is electron donating, so that is why E activation is less than benzene. And in this further ortho and para are having less E activation as compared to meta, and only this is due to the more stabilization of intermediate via presence of more stable resonating structure. So, thus we can say arenium ion formed by attack at ortho and para position is more stable. So, methyl group which is having plus I effect is ortho and para director. Now, second case we take aniline. Now, NH2 group is attached to benzene ring. So, this is having a electron donating mesomeric or resonating effect. Lone pair of electrons are present on nitrogen which can be donated to the ring, and due to this donation we can see negative charge of the ring increases, and this increase is more on ortho and para. These two negative charge on ortho and here the negative charge is on para. So, the electron density of ring increases, but it is more increase on ortho and para positions, and we can see in their attack also. If we see the ortho attack of an electrophile, so instead of 3 here we are getting 4 resonating structures, and this is the extra resonating structure and which is even more stable, because here octet of each atom is complete. In this carbon is having, in these 3 structures carbon is having 6 electrons, but here each atom is having a octet. So, now here we get one more resonating structure which is more stable. So, due to which stability of intermediate arenium ion increases more here. Now, meta attack. In this, if we see by the attack of electrophile on meta position, there are formation of 3 resonating structures of an intermediate in which none is more stable, and the fourth one structure like in ortho attack is absent here. If we see the para attack of an electrophile, here again we see this is the extra stable which is also present like ortho attack, and which is again more stable with the same reason, because octet of each atom is here complete. Thus, arenium ion formed by attack at ortho and para position is more stable. So, amino group is having plus R effect, thus ortho and para director. Similar cases of phenol where OH is attached to benzene ring. Now, again oxygen is having a lone pair of electrons which can be donated to benzene ring, and due to which negative charge comes on ortho and para positions. So, that is why this is also a electron donating resonating effect, and attack will takes place here on ortho and para, that similar to aniline case. Now, next case is nitrobenzene. Here nitro group is attached to benzene ring. So, if we see the resonating structures of nitrobenzene, then we see this nitro group withdraws electrons from the benzene ring, and due to which a positive charge comes on ortho and para position. So, nitro group is electron withdrawing, it decreases the reactivity of benzene ring towards electrophilic substitution reactions, and positive charge is coming on ortho and para. So, ortho and para positions are more deficient in electrons. So, that is why the attack here will take place on meta position, which is unaffected here. There is no electron addition or no electron withdrawal from the meta. So, we can see here in ortho attack also, if electrophile attack on ortho position of benzene ring, then we get this resonating structure, intermediate arenium ion, in which positive charge is present on this carbon, which is directly linked to nitro group, and nitro group is an electron withdrawing group. So, it intensifies the positive charge. Intensification means this resonating structure becomes extra unstable. So, contribution of this structure towards resonance decreases. So, out of these three, one is less stable. So, contribution towards resonance is less. But if we see the meta attack of an electrophile, these three resonating structures are formed, but none of these is extra unstable. All these three are equal contributing towards resonance. Now, para attack, in this again we get the one of this resonating structure which is extra unstable. Here again the positive charge comes on that carbon which is present next to nitro group. So, due to the presence of this nitro group, this intensification of positive charge takes place, and due to which this structure becomes extra unstable and contribution towards resonance decreases and E activation increases. We can see this energy diagram also. So, if we compare with the benzene, benzene is this one, because nitro group is an electron withdrawing inductive effect. So, it withdraws electrons. So, that is why this is having a high E activation as compared to benzene, and in this ortho and para is having much higher than meta. So, reason is again we have discussed, in ortho and para contribution towards resonance is less as compared to at meta. So, that is why meta intermediate arenium ion is more stable as compared to ortho and para. So, we can say arenium ion formed by attack at meta position is more stable. So, nitro group which is having minus R and minus I effect is meta director. Now, next molecule is chlorobenzene. Now, here chlorine is attached to benzene ring. Now, chlorine is having a electron withdrawing inductive effect, that is minus I effect. So, it withdraws electron density from the benzene ring. So, that is why it is a deactivating group like nitro group, but like nitro it is not meta director. It was observed that the chlorine is ortho and para director. There is a attack of electrophile on ortho position, and here we get the formation of 4 resonating structures. This lone pair of electrons from the chlorine. So, this double bond is arises and chlorine gets positive charge. So, here this is more stable. Why? Because octet of each atom in this structure is complete. So, here due to only this electron donating mesomeric effect, this structure get stabilizes. So, there is a instead of 3, 4 resonating structure, and out of 4 one is extra stable. This case is similar to aniline and phenol. Now, in meta attack, if we see the electrophilic attack at meta position, there are 3 resonating structures, but no structure is as stabilized as in case of ortho, because there is no positive charge present on next to chlorine. This carbon is not having positive charge. So, this lone pair of chlorine is not in conjugation with this positive charges. So, that is why there is no extra stable resonating structure. Now, in para attack again we get this extra stable resonating structure, because here again the positive charge is on carbon next to chlorine and which is in conjugation with the lone pair present on chlorine. So, due to which there is this extra stable resonating structure. So, due to which contribution towards resonance is more. So, we can see energy diagram. So, this is benzene which is having a low E activation as compared to chlorobenzene, because chlorine is having an electron withdrawing inductive effect, but due to its electron donation mesomeric effect, it stabilizes ortho and para intermediate arenium ion more stable as compared to attack on meta position. So, we can say chlorine is deactivating group, but it is ortho and para director. So, we can summarize the ortho and para directors like this in 4 categories. We have a strongly activating groups like NH2, NHR, dialkyl and a hydroxy group, and these are the moderately activating groups in which we have a alkoxy group and NHCOR group, and we have a weakly activating where we have a alkyl, phenyl, ester grouping, and then we have a weakly deactivating group in which we have a halogens and we have a this CH2Cl group also, which is a weakly deactivating, but all these groups instead these are deactivating are ortho and para directors due to their electron donating mesomeric effect. Now, meta directors, there are 2 categories for these groups: moderately deactivating, for example nitrile, sulfonic acid, aldehyde, ketonic, carboxylic, ester, COCl group, acid chloride, amide group, and strongly deactivating groups are nitro, ammonium ions, CCl3, because here this is a trichloromethyl group, here 3 chlorine are attached to a carbon. So, that is why these 3 chlorine exert electron withdrawing inductive effect. So, that is why this becomes strongly deactivating group, and similarly CF3 also. We have discussed the cases in which only a mono substitution is present on benzene. Now, if 2 substitutions are present in benzene, then if third group enters, then on which position this third group will enter. So, there are different cases. So, that depends upon the nature of 2 groups which are already present in the benzene ring. So, first case, if we see the group which reinforce each other, means when 2 groups which are present on benzene ring, this directs the incoming group on the same position. For example, this is a methyl which is a electron donating inductive effect, and this is also a methyl which is having a electron donating inductive effect. So, these 2 are ortho and para director. This position is ortho to this methyl and this is para to this. So, both the groups orient the incoming group on the same position. So, this is the reinforcing of both the groups on the same position. Here one group is electron donating, one group is electron withdrawing. So, this position is ortho to this electron donating, because this is a ortho and para director, and this is a meta to this nitro group which is a meta orienting group. So, this again this position is favorable because of presence of these 2 groups. It is a ortho to this methyl and meta to this nitro. So, that is why incoming group will attack on this position. Now, second case, if ortho and para directors and meta directors are not reinforcing, means both are not indicating the same position, then ortho and para directors controls the orientation. Now, see the example, para nitrochlorobenzene. Here chlorine is ortho and para director and nitro is meta director. So, here if because this is ortho to this, but it is not meta to nitro, it is a para to nitro. So, here when these two groups are not reinforcing each other, then this chlorine, because this is a ortho and para director, it governs the orientation of incoming group, and that is why these two positions the incoming group will attack, and major will be taking place on para to the chlorine atom. Now, in second case we have a meta-nitrotoluene. Here again this methyl group is ortho and para director and this is meta director, and this in this the attack will takes place where this methyl group governs the incoming group, that is ortho and para to methyl, and major is on para position. Now, third case, when a strongly activating group competing with a weakly activating group, then strong group controls the orientation. For example, we have this methoxy group and methyl group, where methoxy is moderately activating and methyl is weak activating. So, incoming group orientation will be governed by this methoxy group. So, incoming group will come ortho and para to this methoxy. Para position is already blocked. So, incoming group will come on this ortho to this methoxy group. Now, second case, here we have a OH and methyl group. Now, OH is a strong activating and methyl is a weak activating. So, incoming group will come on ortho and para to the strong activating group, that is OH. So, these are the sites of attack for third group. Now, the fourth case, when two weakly activating or deactivating groups or two strongly activating or deactivating groups compete, then both the isomers are formed. Means when two groups present are of same nature, for example, chlorine and methyl, both are weakly, this is weakly activating, this is weakly deactivating, but both are ortho and para directors. So, this ortho position is meta to Cl and this is meta to methyl, but here both isomers will get formed, ortho to this chlorine and ortho to this methyl. Now, the last case, a very little substitution occur in the sterically hindered position between meta substituents. So, these two methyl groups are present, this position is ortho to both of these methyl. So, incoming group, because both are ortho and para director, so incoming group can enter in this position also, but as these two groups are present and this is in between these two groups, so that is why this position is sterically hindered. So, that is why attack will take place major on this position and this position, and this isomer will be of less percentage. So, today we have discussed the effect of substituent present on benzene ring on reactivity and orientation, and we have seen if electron donating substituent is present on benzene, then it increases the reactivity of benzene ring, but if it is electron withdrawing group present, then it decreases the reactivity of benzene ring, and the reason is the stabilization of intermediate arenium ion in case of electron donating groups and destabilization of intermediate arenium ion in case of electron withdrawing groups. And further we have seen that the electron donating groups directs the incoming group to ortho and para positions, and electron withdrawing groups directs the incoming group to meta position. Again the reason is same. In case of electron donating groups, the arenium ion formed as at ortho and para positions are more stable as compared to meta attack, but in electron withdrawing groups, the arenium ion formed at meta position is more stable as compared to ortho and para positions arenium ion. But we have seen one anomaly also, that is of chlorobenzene. in which chlorine is an electron withdrawing group due to its electron withdrawing inductive effect, but it is ortho and para director due to its electron donating mesomeric or resonating effect, and that is why it decreases the reactivity, but the incoming group will come on ortho or para position because of stabilization of arenium ion formed at ortho and para as compared to meta position. So, in the next lecture we will discuss the synthesis of alkyl benzenes and reactions of alkyl benzenes. Okay.